Hello everyone, I'm Perfon, and incredibly, I won the solo award in the latest Epic Games MegaJam. So now I'm officially one-man army, and to thank you all for supporting me in this throughout this journey, I'm going to break up this game in this video and show you how it was done. So thank you again for all of your support. This is the game Container City, and this was the solo winning game that I made. So let's exit back to the engine, and let's see how it was made. So first of all, the Epic MegaJam obviously it requires the Unreal engine, so this was the engine that is it's used, and it was a 7-day jam, so I created a lot of things throughout this during this time. So first of all, here are some of the models. The very first model that I added was the container. Initially, I just used the box as the testing object, but pretty soon I replaced it with this container. And as you can see from close up, it's actually quite a simple model. I pretty much took the initial box. I added a bunch of loop cuts and moved the vertices inwards. Also, I made it from one corner. The rest of the corners were mirrored. So yeah, it actually was pretty fast to make. I also experimented with some light fixtures to show the power on and off state, but in the resulting game, these were cut because it looked a bit silly and maybe too futuristic that I wasn't intending. There were also some additional models, the buoy, for example, the cable sockets, but overall they are all quite low poly, and yeah, here are the different windows and also doors that were meant for the game, but only the windows passed through the cut. And also some of the bigger models like the Eiffel Tower to set the mood for the game, or like a big skyscraper building. And yeah, initially I thought I would not manage to make those models, but I had like 15 minutes left over at some point, and very quickly put together some low poly models. Yeah, here's the platform, for example. This one I probably spent too much time for what it was worth. So yeah, really simplistic 3D models with an auto UV layout, or using the automatic unwrapping options. So yeah, and then these were imported to the game. I also experimented with animations quickly. That was actually my first animation that I did for the first time I actually tried to import the animation, like regular animation from Blender to Unreal. I had experimented with some character importing before, but not with just basic animations. So it turned out to be super easy. as you can see, I have this regular armature, and that is binded to the guy object, and it's looping up and down. And yeah, I pretty much just exported the same model, and everything just worked. So yeah. All right. So in the engine, in the models folders, I have added all the models and material instances for them all. Basically, for most of the objects, there is just one main or base material, where from which everything else is inherited. That has a basic like paint and normal textures. So yeah, and all the other materials pretty much are inherited from this one. So the other ones are just material instances. All right. A little bit more about graphics and materials. I also made a glowing material, which is just one that outputs the color to the emissive property, and Unreal applies bloom to it, which makes the windows glow nicely. Also hologram material for the placement shape. Initially, I tried to use a transparent material for that one, but it didn't work very well with the water surface that is also transparent. So instead, I'm using the masked option, which pretty much makes an alpha cutout. So it pretty much decides per pixel whether to draw it or not. And it uses the noise texture, the Fresnel, and combines them to make this nice hologram looking shape. So most of the result is just outputted to the opacity mask that determines the dithering. All right, so I think these were the main materials that were used, and to make the rest of the scene visuals, I used Unreal's built-in water and sky materials. These are from corresponding plugins. And yeah, the newest Unreal has a very cool water system. It simulates Gerstner waves. To be honest, initially I started implementing my own Gerstner wave materials, but these kind of I spent some valuable time on it, and it didn't and yeah, I ran into some trouble. So yeah, it's good that Unreal has such things built into it itself as well. All right, and the material uses the volumetric sky materials that are also really nice and ray traced and also performant. I was really pleasantly surprised how fast they are calculated. I tweaked the material a bit. Initially, this billowy sky material. It is meant for just for some weather painting. So you can paint some areas where the clouds should appear. But instead, I wanted to be just constantly cloud covered and also dynamic. So I modified this material a bit uh, I pulled out the painting like system and just replaced the weather map with a static texture, a noise texture, and yeah, then I could use the time value to scroll through this texture and make it animate. All right. The visuals, the atmospheric visuals, are made up by these components. There is exponential height fog that looks really nice. So, yeah, you can see the properties here. So, light source, regular direction light. Also, sky atmosphere. Yeah. That is responsible for this volumetric sky and volumetric sky atmosphere effects. Yeah, and skylight for capturing the reflections from the sky. So I made everything dynamic, so the game could just rotate the light source and animate the visuals or the day cycle display. So the sky atmosphere, and the volumetric clouds from the plugin as well. Yeah, these are the values. And that makes up the visuals. All right. Then the water is just from the plugin content. There has to be terrain for this water system to work. So I threw in I just made a terrain landscape which has this water on, and painted it to be below the water surface. All right, and now let's take a look at the blueprints and other stuff that's in the game. The UI elements, these were made with Affinity Designer. I really like this software for making UI. It's relatively non-expensive vector art tool. That's it just has one-time purchase, and it's for me it does everything that I need pretty much. So yeah, it's a very powerful vector editing software. And I made the UI on a single texture sheet. And then it has this cool export persona functionality that allows to define different areas on this texture and then just export them all in different images with just one click. I can click this export slices button and it re-exports everything, and I can drag and drop them into Unreal. So now let's take a look at the game, how this one is made. So different levels are put into different scenes. So basically they are all the same scenes initially that are just duplicated, and some of the the platforms are switched, the platform instances. So yeah, I can go to the Paris and it's pretty much the same scene with different background assets and different different platform instance. Then the platform, I have the one like main platform blueprint, and like child blueprints or that are inheriting the main platform that just that just have a different configuration of these sub objects. Some of the other platforms are disabled, so they are not shown. So let me go back to the main platform. The platform has a buoyancy component. This is also comes from the plugin content, and it allows to make it buoyant and float on the water pretty much. And all the different buoys that the player can place are also placed here inside the platform. So they are just revealed when the player builds them, but they are here from the get-go. And actually only the very first, like the cube object that is kind of invisible, has any real mass whatsoever. So it has like 2,000 kilograms. I mean, while all the other objects have really small mass. And the reason is that I couldn't get the buoyancy dynamically adjustable. So instead so initially I thought I could just dynamically adjust the buoyancy values based on how many buoys you have, but this one didn't work. So instead I just start with a really high mass on the circle middle box, and decrease it as the player adds more buoys. So to kind of it's a little hacky solution to get the weight adjustment working pretty much. So the platform itself doesn't do much. It only handles the buoy placement logic. So yeah, changes the buoy material when it's hovered, and decreases the mass when so when the place buoy is called, then it decreases the mass of the cube. All right, but instead the clever logic happens. The main logic happens in two scripts, in the game mode and in the player controller. And these are the scripts where most of the Unreal Engine logic should happen. Should happen in any game. So first of all, let's take a look at the game mode. So the game mode is responsible for controlling the game flow pretty much, or the game session. So, and it also handles it stores the time value, so it knows what's the day progress, and it also is responsible for handling the tutorial, and knows when the day starts and ends. So yeah, when the game is set up, it checks based on the level name whether it should have the tutorial or not. It gets the directional light that it changes for the day cycle, and then yeah, it just it is also responsible for giving the options of selectable cards at the end of the day. So it makes the card choices as well. Yeah. So we can take a look at the time function. So it's here in the tick. It just increases the time value, and yeah, it calls the set time function that does the time-based calculations and checks if the day is still running or not. The time-based check or the set time function that ticks every frame. Here it updates the HUD. It changes the progress bar on the HUD, and it also changes the rotation of the light source. Yeah, and updates the tutorial in different. Yeah, the tutorial just checks what's the time and sometimes shows the corresponding tutorial card. Yeah, then it has functions for starting and ending the day. So when a day day ends, it tells the HUD to end the day, disables the player input and puts the game on pause. And when the day starts, it just adds a lot of new guys, like calculates based on the day number how many new guys to add, and also sometimes changes the day length, so that for the tutorial some of the easier days will pass quicker. And yeah, so it has also some functions for assigning people to the houses. All right. So next, the second important game object is the player controller. So the player controller it is responsible for all the player inputs pretty much. So it's a custom player controller implementation. It's also responsible for storing the player's inventory. This is stored in a dictionary of a string and count. And yeah, player controller also creates the HUD widget, so it has the reference to the head-up display. And yeah, it also knows the hologram object that shows the placement location. And yeah, it is responsible for the cards that are selected in the UI as well. So it knows what are the currently selected cards. All right, and then it has functions for doing stuff when the player presses the mouse button, for example. So when the mouse button is pressed, it checks it checks what card is selected from the in the UI, and based on that, it determines what the player can place: a container, buoy, cable, or something else. And it has different functions for placing different things. But yeah, these are also relatively simple. It does a ray trace under the mouse. So yeah, here's the ray trace simplification function. And then it just takes the hologram position, calculates another position a little bit upwards from the hologram, and spawns the container to that position, and lets the gravity to drop it in place, and of course place the audio as well. And functions for placing the solar panel and cables. The cable logic is a little bit more complex. And for sometimes some placements are different, like buoy placements, because these are already connected to the platforms, as you saw, and update hologram function is called every frame. It traces also the mouse position, and places this hologram where it should be. So event tick updates the cable placement and hologram placement. All right. So next, let's take a look at these cool objects as well. So what they are doing. For example, the container. It is made of the container and its windows. The windows are child actors, so they can have their own behavior. The light sources, I'm lucky that I disabled in the end, because it looks a little bit silly. But each window is its own child actor. And at the beginning of the game, it changes its parameters based on the color, for example. As we can see, the color value is instance editable and exposed on spawn. So it can just, when it's spawned, it's just a argument that is given to the spawn script, and and here in the begin play method, it sets the color for all the windows and to itself. Here it sets its own material, creates a dynamic material instance and changes the color of it. And then it has to deal with the power changes. For example, it has methods for powering it up, and when it's powered up, it calls the open method for all its child window actors. So initially I was planning to also sometimes disconnect the power, but this didn't get into the cut. It was I had to cut it through to time constraints. All right. So this is its logic. I can quickly show you the window as well. The window is here. So in the window actor, I have methods for opening and lighting it up or lighting it down. So lighting it is really simple. It just switches the material to the glowing one. An opening one is quite simple as well. It uses a timeline. So it has a timeline that animates one float property, and in timeline tick, it just uses this animated float property to set the rotation of the left cover and right window cover, and moves the window sill as well. So so it programmatically opens up the window. All right. So the cable logic is also quite interesting, I think. I actually the first solution like got really messy, but the cables themselves are just are Unity, I mean Unreal's cable component, and this all already can like it can get the length and it can already take the shape of the cable, so it looks really nice. But it has to be attached to something, and this is done by these connections. So it has these connection objects, and under each connection object there is also a like just an empty scene component for storing the actual location where the cable attaches, so that the connection connector itself connects to the house or building, and the scene component is a little bit moved a little bit further to that connects to the cable, and yeah, so initially I tried to do it without the additional connections by calculating the vectors myself, and it got really messy. So setting up the parent structure can save a couple hours of work. So quickly we can see what happens here. In the begin play, it sets its visuals, and then it has updating functions to that will be called while the player still holds down the mouse button. So here's the event tick that changes the position. And finish placement. When the placement is finished, it just calculates a new length for the cable to make it and adds a little bit to the distance to make it not completely stretched out and straight, but make it wobble a bit. All right, but the physics I would like to show this one as well. So the physics is calculated in the tick event. So basically it checks if both of the actors are valid, so it is connected to some stuff or to the correct stuff, and if it is, then it applies some force to both of the actors. So and the force is calculated such that it's it's equal force the it is equal force that pretty much pulls both objects together when they get more apart. So it knows the original distance, how long the cable should be originally, and then it and then it calculates how much longer it has become. So and if it is longer, then it's pulling the actors together to like so it kind of like tries to retrain its original distance. Initially, I didn't use the original distance. I just took the distance as the pull amount, and this produced a nice like springy mechanic where these cables like pulled everything together. But yeah, it wasn't so good for the desired gameplay. But it would be a nice tool to give for the player in the actual game, so they can also manage the load by adding different springs between containers. All right. So next, let's also take a look at the UI. So UI typically takes quite a lot of time to get right, and it took from me too. One more thing. So the data, the game has two data classes as well. So these are just structs for the card data. One moment. So the card structure has name, icon, and default amount. And the cards, they are. I've added the data. I'm using the data tables for actually defining the data. So the data tables, like TD cards, holds the information about all the existing cards and how much there is by default. So I'm just filling up these data tables to define different data. And the second data is the card choice data. This has pretty much two name variables for both for referencing both cards and count. So these will determine different choices that the player will be given. And the card data, not card data, but the card choice data table has these different possible pairs of things. So this way they are not like completely random and a little bit more balanced. So the options will be like equally good, and some of the options will be more likely than others. So here I'm defining different pairs, how many cables and buoys will be offered, for example. Now then the UI. It's under the under the UI. I have a couple of widgets. So there is a UI for the head-up display, for example. So this is like the most significant UI, and everything is this was created by the player controller and put to the viewport. And here, what it does, at the beginning of the game. Let me try to find this location. So at the beginning of the game, it clears its card buttons, for example, and then it calls add cards. That just loops through the data table rows and adds a card like widgets for each of the cards, each of the item that the player has. And it has some additional things as well, but now we can take a look at the card button. Card button. So this is the little icon that the player can press. It has functions for changing the effects, for selecting it, hovering it, and to add this kind of nice looking animations to the UI. It's relatively simple. Right in the user interface system, the user can create multiple animations to like animate the cards differently. So the hover has a little bounce, as you can see. And when the button is hovered, for example, and not selected, then it plays the hovering animation. And yeah, so these little polishing details give a nice feel to the UI. Here as well, it unhovers it probably. And when the button is pressed, so on pressed event happens on the card button, then it calls the its own onSelected event. This onSelected event is then binded in the HUD. So you can quickly see when the cards are created, add cards. After they are added to the card containers, they are, for example, the onSelect event is binded, which will then change the it will disable all the other cards and set this card to be selected. So yeah, that's the overall the design architecture. And as you can see, it takes some time to put it together, but it's but a similar architecture can be used in everywhere pretty much. Adding different options, and I think in Unreal it's quite well made. All right, is here something else left over that I should talk about? I think I've covered most of the things. So yeah, I hope this little video, I hope it was interesting and educational. And thank you for watching this video. Also, don't be sad if if you didn't win any prizes on yourself. It was a competition after all. and I have also made participated in previous jams where I've done quite poorly myself. So so it's part of luck as well. And overall, I'm happy how it turned out. I pretty much I had to work till the very last minute, and even in the last day I was a little bit worried about the scope of this project. I wasn't sure if I was able if I would be able to finish it, but in the end I somehow find the time and pull it together. So yeah, thank you all for supporting me. Also, check out my main project called Blastronaut. It's I'm working on this game really hard as well. It is you should wishlist it on Steam and help me out, because getting views is hard. and yeah, check out Blastronaut. Thank you for watching, and keep jamming. Learn Unreal Engine. It's a cool game engine to make jam projects. All right, thank you for watching, and I'm out. Goodbye.